Hi, welcome back. So we're in Chapter 3, Descriptive Analysis on the study of dispersion. And in particular, we're going to study the range tool. Now, from the definition, as the name indicates, range refers to the distance between certain value. The range doesn't really work or indicate anything in the case of the variable outcome happens to be discrete, but it works if the outcome or the value space happen to be in a continuous form. You would have this vector. The first step to do, look at them in ascending order, the minimum value here and to the maximum value here. And the simple formula for range is straightforward, is to take the maximum subtracted from the minimum, and here you go, you got your range. Range can be helpful, but unfortunately, since it involves only two numbers to extract the indication of it, it doesn't really tell you much of intuition. The second flow in it, if you would have a data set with outlier inside the vector, then the range will be completely misleading. Let me show you an example. Imagine I have this data set and you get range of 195. Now this range is quite large. What it tells you that from the point of 5 to the point of 200, the values are inside here, seems to be in a range of 195. So your value might be here 10, somewhere else might be 180, sometimes could be maybe 90. So all this range is covered according to the value of range that I extracted. That's completely untrue because I can see the majority of values I have in my vector are within a very little range. Because of this outlier, the information was misleaded. In fact, if I want to correct that by eliminating this outlier and taking 30 minus 5, that will lead you to 25, which is quite correct. Range on its own doesn't help you, and range can be really affected by the outlier, but it's perfectly okay to have a combination with other measures. Next, we will be looking at a much higher intelligent tool that can be better intuitive, and that is to study the interquartile. I will see you then.